All right, this is from section 14.3, and it's simplifying expressions. And I'm going to go through 6 examples. You can kind of decide how many of these you need or want to watch, or maybe you watch a few now and a few later. But some of these will be very challenging, and some of them will be fairly simple. So this first one says 1 divided by sine of pi halves minus theta times cotangent of theta. And simplify, of course, just like simplifying anything, you want to get it down as small as you possibly can. Okay, so I'm going to remind you of your trig identities here, none of them which you have to memorize, okay? And I'm going to talk about this one. Okay, so sine of pi halves minus theta. Well, I know over here sine of pi halves minus theta equals cosine theta, so I'm going to substitute that in. Okay, so, whoops, don't want to go crooked. So I know that this is going to be 1 divided by cosine theta. Okay, and again, this came from this trig identity, which I know you can't see now, but that's, I just am substituting that. Well, then I know cotangent, or you should know, cotangent is cosine over sine, because tangent is sine over cosine, so cotangent is the reciprocal of that, so cosine theta over sine theta. And again, nothing you have to memorize. Look at there, cotangent is, cotangent is cosine over sine. Okay, so nothing you have to come up with, although I think you know that one. Then it's pure algebra. You know the cosine of thetas cancel out, right? And then you have 1 over sine theta, and you know that 1 over sine theta is the cosecant. And that is as simplified as we can get. All right, this one gets a little bit bigger, so I'm going to give you a little hint. Notice how you have a lot of tangents, secants, cosecants. If you can get everything in terms of sines and cosines, that usually ends up helping you out in the long run. Not always 100%, but usually. So I'm going to take anything that's not a sine and a cosine and try to get it in terms of sines and cosines. Okay, so starting with the first expression here, tangent I know is sine divided by cosine. Okay, so I'm going to change that to sine theta divided by cosine theta. And then secant I know is 1 divided by cosine. Okay, so I know I'm making it bigger and looking messier, okay? But now I know that I'm going to take this and multiply by the reciprocal of this. Okay, so this is really times cosine theta over 1, and then I'm going to get rid of that. And then notice the cosines cancel out, right? Here. So I have sine theta. Okay, so this expression is really just sine theta. Okay, so again, I changed tangent to sine over cosine, secant to 1 over cosine, multiplied this by the reciprocal of that, and ended up getting sine. Well, then it's times another sine, so sine times sine, of course, is sine squared, so I'm just going to toss in the square. All right, then the second chunk, tangent, is sine over cosine, so sine theta over cosine theta. Cosecant is 1 divided by sine, so I'm going to change that, and then times cosine cubed. Well, here my sines cancel out, right? And here this cosine will cancel out one of these, so I'll just have a cosine squared left. And oh my goodness, we have the Pythagorean identity, right? So just writing you here, sine squared theta plus cosine squared theta equals 1. And that's exactly what we have, sine squared theta plus cosine squared theta. So that is really just 1. How cool is that? That huge mess of stuff is just 1. You gotta love trig identities. All right, this one says sine of negative x over cosine of negative x. Notice the thetas are x's now, and that's totally fine. Please understand that, theta, x, y, whatever, they can be any variable, really. So I'm going to take a peek at I guess I would notice, oh gosh, I have negatives here with my sines and cosines. So going over to my identities that I don't have to memorize, I notice that the sine of negative theta is negative sine of theta. And I note that cosine of negative theta is a positive cosine. So, keeping that in mind, I'm going to make that a little smaller here. And I know you really, maybe you can still kind of see that. But again, sine of negative x is going to equal a negative sine of x. And cosine of negative x equals just a positive cosine of x. And I know sine divided by cosine is tangent, so that's really tangent of x, but negative divided by positive is negative. So that's just negative tangent of x. And that's kind of an example of a nice easy one. All right, this one, depending on what route you take, can be really easy. So I'll go that route first. Cosine squared x plus tangent squared x plus sine squared x. Well, again, according to Pythagorean, we know that sine squared plus cosine squared is 1. So, using that, I know that cosine squared plus sine squared is 1. So this is really 1 plus tangent squared x. Okay, then, and anytime you have something squared, by the way, I would look at the Pythagorean identities because all that stuff is squared. Okay, then maybe over here, I hope you can see this okay, you can see that 1 plus tangent squared equals secant squared. So this is really just secant squared x. And then in terms of secant squared x, the only thing you could really do at that point is turn it back around to something bigger. You do know that secant is 1 over cosine, so you could also write 1 over cosine squared x. To me, secant squared x is just as simplified. So that is good enough. And so I just want you to understand that it might not be like you get down to one thing, like just secant. It might actually be something squared or whatnot. Now another thing that might happen is instead of recognizing that this is 1, you might say, oh, well, tangent squared x over here, and you can rearrange this, right? So tangent squared x, if I erase that extra square there, is secant squared x minus 1. So again, this plus 1, I could minus it. I mean, you can rearrange these, of course. I'm sure that makes sense to you. So if I substituted that in for the tangent squared x, and I'll actually write this out, I'd have cosine squared plus secant squared minus 1 plus sine squared x. And then hopefully at that point you'd realize cosine plus sine is 1. So that is 1 minus 1 cancels out, and you'd have secant squared anyway. But unfortunately with these, that's what makes it hard, is if you take a longer route, you just might not get there. So I'm trying to give you clues. So if it's anything squared, use the Pythagorean identities. If there's lots of stuff, try to get everything in terms of sines and cosines. All right, I like this one because it takes a little bit further. So you have cosine plus sine times tangent, and that's all x. So again, my hint was, you know, if you can get everything in terms of sines and cosines. So I'm going to change tangent to sine over cosine. So I'm going to have cosine x plus sine x times sine x over cosine x. So I just changed tangent. Doesn't look better, that's for sure. And of course this is over 1, so I have cosine x plus sine squared x over cosine x. So again, I just multiplied these two to get sine squared. Still doesn't look so good. If you're at a point where you have a denominator and something that's not, or you know, this is technically over 1, but it doesn't have a denominator, find an LCD, a common denominator. Okay, so again, this is really over 1, so the common denominator is definitely cosine x. So I'm going to multiply this one by cosine x over cosine x, right? So cosine squared x over cosine x plus sine squared x over cosine x. Then you have a common denominator. So cosine squared plus sine squared, Pythagorean identity. By the way, you're going to use that one a lot. Cosine squared plus sine squared is just 1, so that's 1 over cosine x. And again, because I have a common denominator, I can add these together, which just equals 1. My common denominator stays my common denominator. And of course, you know 1 divided by cosine x equals secant x. All right, last one I'll walk through says 1 minus cosine squared x divided by cosine squared x. And you could go about this one many different ways. And let me stress again that the frustrating thing about these problems is you might start out a different way than I do. You might take the easier path. I might take the harder path, the longer path. And that happens. So don't let these frustrate you. Just like anything, you really just have to practice these over and over again. And some of you are going to love it because it's like solving a puzzle. Alright, so this one, you have 1 minus cosine squared x divided by cosine squared x. These are both squares in case you can't see it. I got a little squished. So again, I have squares, so thinking Pythagorean over here. I don't really have any squares. Well, I'm sorry, I do. So, okay, sine squared plus cosine squared equals 1. If I rearrange that, for sine, solve it for sine squared, I'm going to subtract the cosine squared over. And now can you see that this is this? So I can substitute sine squared for that numerator. So I'm going to have sine squared x, I'm using x's instead of thetas of course, over cosine squared x. And I know sine divided by cosine is tangent, so anything squared over anything squared is going to keep it squared. So that's really just going to be tangent squared of x, and then anything I do to tangent is just going to make it bigger, so that's it. Another option, and I don't know if you saw this necessarily, but if I write both of the numerator pieces over its denominator, I'd have 1 over cosine squared plus cosine squared over cosine squared. Okay, so then this is just 1. This is really secant squared, right, the reciprocal. So I have secant squared, that's a minus, sorry, minus 1. Well, now again, over here, the second one, if I solve that for tangent squared, I would subtract 1. Whoops, I always do that. Secant squared minus 1, and then I can see that this and this are identical, so that it equals tangent squared. So, I don't know, that's a couple ways. Now that's, like I said, there are oodles of ways to go about these, so hopefully, I hope for you that you take the easiest route.